Hello, I'm Tony Cole, the host of TalkIT Global. Recently, at the CES2026 keynote, NVIDIA CEO Jensen Huang announced that NVIDIA and Mercedes-Benz plan to launch an autonomous vehicle based on Alpamayo, an open-source autonomous driving AI model, within March this year. In this episode of Seminar, we'll explore how NVIDIA leveraged open-source AI models to build autonomous vehicles. To train a self-driving car, one of the biggest challenges is preparing data that represents a wide range of real-world physical driving environments. Let's take a closer look at how NVIDIA addressed this challenge using Cosmos, its open-source world foundation model.
How do we teach an AI the ground truth of physics? There are lots and lots of videos, but hardly enough to capture the diversity and the type of interactions that we need. And so this is where great minds came together and transformed what used to be compute into data. Now, using synthetic data generation that is grounded and conditioned by the laws of physics, grounded and conditioned by ground truth, we can now selectively, cleverly generate data that we can then use to train the AI. So for example, what comes into this AI, this Cosmos AI world model on the left, over here, is the output of a traffic simulator. Now this traffic simulator is hardly enough for an AI to learn from. We can take this, put it into a Cosmos foundation model, and generate surround video that is physically based and physically plausible that the AI can now learn from. And there are so many examples of this. Let me show you what Cosmos can do.
The ChatGPT moment for physical AI is nearly here. But the challenge is clear. The physical world is diverse and unpredictable. Collecting real-world training data is slow and costly, and it's never enough. The answer is synthetic data. It starts with NVIDIA Cosmos, an open, frontier world foundation model for physical AI. From driving telemetry and sensor logs, surround video. From planning simulators, multi-camera environments. Or from scenario prompts, it brings edge cases to life. Developers can run interactive closed-loop simulations in Cosmos. When actions are made, the world responds. Cosmos reasons. It analyzes edge scenarios, breaks them down into familiar physical interactions, and reasons about what could happen next. Cosmos turns compute into data, training AVs for the long tail, and robots how to adapt for every scenario.
Can a self-driving car experience every possible unexpected situation on the road? In reality, that's nearly impossible. That's why NVIDIA's open-source autonomous driving AI model, Alpamayo, takes a different approach. Instead of learning everything end-to-end, it begins by decomposing situations, separately understanding surrounding objects and physical laws, then reasoning through them on its own. Rather than being taught tens of thousands of edge cases one by one, this marks the beginning of an autonomous driving AI that understands underlying principles and makes decisions independently.
Today we're announcing Alpamayo, the world's first thinking, reasoning, autonomous vehicle AI. Alpamayo is trained end-to-end, literally from camera in to actuation out. The camera in, lots and lots of miles that are driven by itself using human demonstration, and we have lots and lots of miles that are generated by Cosmos. In addition to that, hundreds of thousands of examples are labeled very, very carefully so that we could teach the car how to drive. Alpamayo does something that's really special. Not only does it take sensor input and activates steering wheel, brakes, and acceleration, it also reasons about what action it is about to take. It tells you what action it's going to take, the reasons by which it came about that action, and then, of course, the trajectory. All of these are coupled directly and trained very specifically by a large combination of human-trained and as well as Cosmos-generated data. The result of it is just really incredible. Not only does your car drive as you would expect it to drive, and it drives so naturally because it learned directly from human demonstrators, but in every single scenario, when it comes up to the scenario, it reasons about, it tells you what it's going to do, and it reasons about what's about to do. Now, the reason why this is so important is because of the long tail of driving. It's impossible for us to simply collect every single possible scenario for everything that could ever happen in every single country, in every single circumstance that's possibly ever going to happen for all of population. However, it's very likely that every scenario, if decomposed into a whole bunch of other smaller scenarios, are quite normal for you to understand. And so these long tails will be decomposed into quite normal circumstances that the car knows how to deal with. It just needs to reason about it. And so let's take a look. Everything you're about to see is one shot. It's no hands. The model here is called Alpamayo. And Alpamayo today is open sourced. This incredible body of work, it took several thousand people. Our AV team is several thousand people, just to put in perspective. Our partner, Ola, I think Ola is here in the audience somewhere, Mercedes, agreed to partner with us 5 years ago to go make all of this possible. We imagine that someday, 1 billion cars on the road will all be autonomous. You could either have it be a robo-taxi that you're orchestrating and renting from somebody, or you could own it and it's driving by itself. Or you could decide to drive for yourself. And so, but every single car will have autonomous vehicle capability. Every single car will be AI powered. And so the model layer in this case is Alpamayo, and the application above that is the Mercedes-Benz. Okay, and so this entire stack is our first NVIDIA first entire stack endeavor. And we've been working on it for this entire time, and I'm just so happy that the first AV car from NVIDIA is going to be on the road in Q1, and then it goes Europe in Q2, here in the United States in Q1, then Europe in Q2, and I think it's Asia in Q3 and Q4.
Safety is the most critical factor in autonomous driving. So how did NVIDIA implement safety in Alpamayo?
The Alpamayo stack is trained end-to-end and has incredible skills. However, nobody knows until you drive it forever that it's going to be perfectly safe. And so the way we guardrail that is with another software stack, an entire AV stack underneath. That entire AV stack is built to be fully traceable. And it's taken us some 5 years to build that, some 6, 7 years actually, to build that second stack. These two software stacks are mirroring each other, and then we have a policy and safety evaluator decide, is this something that I'm very confident and can reason about driving very safely? If so, I'm going to have Alpamayo do it. If it's a circumstance that I'm not very confident in, and the safety policy evaluator decide that we're going to go back to a simpler, safer guardrail system, then it goes back to the classical AV stack. We're the only car in the world with both of these AV stacks running, and all safety systems should have diversity and redundancy. Well, our vision is that someday, every single car, every single truck will be autonomous, and we've been working towards that future.
Lastly, your likes and subscriptions greatly empower us to continue creating content. Thank you for your support.